Hello everyone, and welcome to webinar 7 in the Refuels Week series. This is the last webinar in our series where we've been looking at the impact and other issues with renewable fuels. My name is Dave Keating. I'm a journalist based in Brussels. We're coming at you live from the heart of the EU quarter, which is abuzz with excitement at the moment with the visit of the US President, Joe Biden. But we're going to be talking today about air quality, the impact of refuels on air quality. Now, so far in this series, we've mostly focused on what renewable liquid fuels would mean for the EU's efforts in achieving climate neutrality by 2050. But air pollution, of course, is a separate issue that can sometimes have a complicated intersection with carbon emissions. The debate about diesel versus petrol, for instance, changes pretty dramatically depending on whether you're talking about air pollution or carbon emissions. Now, addressing air quality and urban air quality in particular has also been identified by policymakers as a priority for the health and well-being of EU citizens. Reducing emissions of pollutants from road transport has been a long journey, but Euro standards for both light-duty and heavy-duty vehicles have been successful in progressively reducing the gap and are now enabling compliance with the emission limits that have been set for NOx, PM, and other harmful pollutants. This has been achieved through the use of more efficient engines, improved fuels, and state-of-the-art emissions control technologies. It's also been achieved through the use of real driving emission testing, and we can now see that modern vehicles on the road are passing these tests, and we see some interesting data for that in recent studies, which we'll talk more about today. So as we look to the future and the emergence of non-fossil-based liquid fuels, the question of low-carbon liquid fuels' performance with regards to air quality has to be carefully analyzed because it is a separate issue to carbon emissions. We know their climate impact, but are these fuels showing better, similar, or maybe even worse results than conventional fuels when it comes to air pollution? Today we're going to discuss this question and hear some of the latest science on conventional fuels performance on the basis of recent studies and tests performed on both fossil and non-fossil fuels. Now, let me introduce you to the panelists we have for today's discussion. Here in the studio with me is Dirk Bostiels. He's Executive Director of the Association for Emissions Control by Catalyst, AECC, which is a Brussels-based scientific association of European companies engaged in the development, production, and testing of catalyst and filter-based technologies for emissions control for mobile sources. Welcome, Dirk.
Thank you, Dave.
Then joining us remotely, we have Paul Greening, who is Director of Emissions and Fuels at ACEA, the European Automobile Manufacturers Association. And we have Philippe de Gaille, Research and Innovation Project Manager at IFP Energie Nouvelle. His research work focuses on the evaluation of the environmental footprint of vehicles in real use. And last year, he conducted a study for the French Ministry of Ecology to assess the emissions in real use of vehicles meeting the latest certification standards. So he's going to be really presenting us with some interesting recent data on this subject. So, Dirk, let me start with you, since you're here in the studio with me. Now, as I mentioned in the introduction, you're involved in catalyst and filter-based technologies. So how are those technologies making a difference for air pollution?
Well, Dave, thank you, and it's good to be here. And I would like, from my side, to welcome you all to this webinar and thank FuelsEurope for taking the initiative and for inviting AECC to be part of this. Yeah, you mentioned AECC. We are a scientific association based in Brussels here and representing the European emission control industry. We have 6 member companies. It's part of the chemical industry, and these companies, they research, develop, and produce the emission control technologies that we can now see today on all modern cars and that are performing very well also in real driving conditions. We as AECC, we see that the internal combustion engine still has a role to play and is part of the future solutions for future sustainable mobility. We have effective means to control very well the harmful pollutants, but we think in combination with the use of sustainable renewable fuels, we also have the means to reduce the CO2 emissions on a well-to-wheel life cycle analysis basis. And what we do as AECC mainly, given our scientific nature, is that we conduct demonstrator projects, and we then disseminate the results of these projects with the legislators in order to impact the legislations and the legislations to come, but also to demonstrate to the public by a wider dissemination what is technically feasible. So I like to share some slides with you today, if you allow, and I think you can see them on the screen now. A typical program that we did as AECC a couple of years ago, we called it the ultra-low emission diesel demonstrator vehicle. So we took a vehicle from the market. You can see the vehicle there on the slide. It's a C segment, so a rather compact vehicle. And what we did is we replaced the original emission control system by a novel system delivered by the AECC member companies, where we apply close-coupled components for effective emission control in low load and city driving and cold start conditions, in combination with underfloor components that you can see on the right, so that we can have really a broad coverage of emission control. And so we demonstrated ultra-low emissions with a focus on NOx over a wide range of driving conditions, but we also validated these ultra-low emissions over several tests using renewable fuels to show that both are compatible. So reduction of regulated pollutants and well-to-wheel life cycle LCA reduction of CO2. We used a couple of fuels for that. I will not go into the detail, you have them there on the slide. And we did the calculations in close cooperation with our colleagues from Konkawi, which I would like to acknowledge here. Next slide, please. Oh, I can do that myself, apologies. So looking first at the CO2 emissions and the well-to-wheel calculation. So what you can see on this slide is on the graph on the right of the slide. You see on the left side of the graph, you see the tailpipe emissions, tank-to-wheel CO2 emissions measured at the tailpipe over the WLTC cycle. And you can see for the suite of test fuels that we used, so starting from a B7 market fuel to a 30% FAME blended in the market fuel, to the paraffinic fuels, hydrogenated vegetable oil, bio-to-liquid, and we didn't test on the e-diesel, but we took it into account in the calculations. And you can see on the right the impact this has on a well-to-wheel basis for the CO2 emissions. So this shows with the results I show you on this slide, where you have the regulated NOx emissions presented over a wide range of speed, vehicle speed, and all the dots that you actually see there are all individual tests that we did from the left, let's say short test in urban driving, like typically the Transport for London cycle, and to the far right, a typical German Autobahn test. You see these areas where the emissions go up in the low load as well in the high load area, and there are some technical explanations for this. But expressed in over a range of speed, you can see that we can actually have very low emissions, ultra-low emissions over this wide range of operating conditions. The bottom graph shows you the efficiency of the after-treatment system, which is always 90% or higher. And you can see actually that there is no contradiction in reducing pollutant emissions, which are important for health of the citizens and also for urban air quality, and reduction of CO2 emissions. And just this final slide as an outlook, as what we will be doing or are already doing this year. We are doing the same, as you can see at the bottom two pictures, on a light-duty gasoline vehicle, as well as on a heavy-duty diesel truck. And there as well, we will not only measure the regulated pollutants, but we will also test with sustainable renewable fuels, including e-fuels. and we are hopeful to present the results of this study in the next months to be part of the ongoing discussions that are happening today regarding CO2 review, but mainly also for the Euro 7 dossier. So with this introduction, Keith, Dave, I would like to thank you for this opportunity.
Thanks a lot, Dirk. And you guys at home are going to be able to ask your questions to Dirk or to any of the panelists using the text bar on your screen that you can see there. Type in your questions and I'll be reading out those questions to the panelists later in the panel. Let's turn to Paul next. So Paul, as I mentioned, of course, is carbon emissions, different issue than air pollution. So when it comes to air quality in particular, what is the automotive industry doing to improve air quality? Paul, I think you're on mute.
Oh. Can you hear me?
Yes, you're back.
David? Okay, thank you. Well, good morning to you, and good morning everybody joining this webinar, and thanks to FuelsEurope for organising it and inviting us. Well, you know, I'm not going to reflect on previous events because they still seem to be in the mind of some parties, but I think moving on from that, a lot has been achieved by the industry, driven also by the regulations which have come in, particularly the passenger car regulations, Euro 6, with the movement from laboratory verification of emissions to on-road verification of emissions, and the resulting final Euro 6 regulation, we believe, is a very good regulation that is demonstrating clearly the improvement in vehicle performance where it matters on the road, not just in the laboratory. Not forgetting, of course, that laboratory measurements are still necessary for standardized and common measurements of CO2, which are necessary as a level playing field for monitoring CO2 emissions against targets, which we have today and which will increase in severity in the future, notably the Fit for 55 package, which is due to be published next month, will address passenger cars and heavy-duty vehicles review of CO2 next year. That being said, it's very clear also that on heavy-duty vehicles, the same applies. We don't have the same sort of RDE type of approach, but for many years now, actually, within Euro 5 and 6, heavy-duty vehicles have been assessed for their emissions performance on the road. We call it PEMS ISC, PEMS in service compliance evaluation. So in many respects, it's like an RDE test. But the key impact there is that the emissions are verified on the road. And both of these European regulations are now serving as models for the development of regulations in other world areas. Areas like the USA, where they have traditionally claimed that their emission regulations are far more efficient than European ones. That might be the case when you look at the numbers on paper and the rigorousness of the testing procedures. And certainly we would agree that the regulatory process in the United States has got some good things which Europe could look at. But when it comes to where it matters, the European regulations that we have today are quite good. Now, that's not to say that we can't do more. When it comes to decarbonisation, you look in the papers, you look in the media, and every day there are new announcements by automakers about electrified vehicles. That's certainly the case when we're talking about passenger cars. And we're seeing also the development of electrified powertrain in the vans and the heavy duty sector, maybe not as fast as cars. That's quite natural because we believe there's still a little way to go there on vehicles which are essentially goods transportation compared to mobility units for passengers. And all of that effort is increasing in the amount that's being done. There's a lot of investment, a lot of efforts being made in electrification. But we shouldn't forget, though, that we're never going to get to 100% sales of electrified vehicles in the near term. You know, the strategy is towards the Paris Agreement of 2050, net zero. And our industry, I think, has been quite clear in a lot of its communications, particularly the heavy duty side recently, with its collaboration with the Potsdam Institute on CO2. That by 2040, we're expecting the great majority of vehicles that are being sold to be effectively zero emission vehicles. And as that progression takes place over the years, you will see a very positive impact on the CO2 emissions from our sector, but also at the same time, the emissions, the pollutant emissions, which are coming from the sector, particularly the one which is the key at the moment, which is NOx. We believe particles are pretty well under control from the exhaust pipe, but we do agree that there is more to do when we have the measurement procedures for assessing the particle emissions from braking systems, which of course won't impact just combustion engine vehicles, but will impact all vehicles. So Euro 7 has been mentioned a few times in debates, and we've been taking part in Euro 7 over the last couple of years in the Commission stakeholder groups. And I have to be very clear that we're not against a Euro 7 regulation, which is sensible, balanced and proportional. But we really do need to see, with all of these efforts on decarbonisation, and also looking at the great benefits which we believe that Euro 6 is delivering, and studies do show that Euro 6 fleet renewal is making a big difference. We really need to see where and how Euro 7 would actually provide some additional benefits to air quality. The Commission's own consultants, for example, estimated the R&D cost of Euro 6 at about $1 billion or so per OEM. That's just the R&D. And we certainly see the same sort of numbers involved in a Euro 7 regulation, particularly one which could be drawn out from the presentations which we've seen from the Commission consultants so far. So we are looking forward to what the Commission thinks about Euro 7 and to hope that we will have a balanced approach to such a regulation that would take place within the next several years. Thank you, David.
Thanks a lot, Paul. So let's turn to Philippe next. Philippe, as I mentioned at the beginning, you've been researching the environmental footprint of vehicles in real use. So what are the trends right now with air pollution?
Thank you, Dave. Good morning, all. I will first like to thank you, FuelsEurope, for this invitation and the opportunity to present our work today. So, of course, there will be a lot to say about the impact and the potential of low-carbon fuels for decarbonization. I focused my results today for the local pollutants, of course. And talking about pollutant emission, there have been a lot of changes in the last 5 years. Now the trend has been very positive in recent years, following the introduction of the last regulation and the wheel driving emission measurement. For today, I will quickly introduce IFP Energy Nouvelle activities on the field, but then focused on an ongoing study that we are conducted with the Concawe. At IFPN, we are focused on the field of energy transport and environment, and mainly focusing 4 main challenges. Of course, the fostering sustainable mobility, diversifying the energy mix, increasing energy efficiency, and improving the environmental impact of fossil resources. And we are facing these challenges with 3 priority areas. Of course, the research and the innovation, the training of the new generation of engineers, and to create value for industry. More specifically on the field of local pollutant air quality. Just an example of 3 projects we are leading concerning the low carbon fuels and air quality. First of all, some activities on the research to produce second generation biofuels with the project Beauty Fuel. I will not detail the focus. And maybe more in link with the air quality, two projects we are leading concerning first the assessment of well-driving emission with the development of smart sensor, for example, in order to assess the emission in well-driving situation at the largest scale possible. Another example with the development of general public smartphone application in order to take into account the impact of his own mobility and to give some tools for everyone to act in order to decrease mobility impact. More specifically concerning the, I don't know if I am on the right slide. Yes, concerning the general context that Dave very well introduced as an introduction, the successive standard very well succeed in decreasing the transport impact on air quality, even if on the past few years we have seen an increasing gap between the standard levels and the real street emission. As an example, on this figure, the NOx emission level compared between the standard levels and the real one measured on the street. But of course, we had a very positive impact of the Euro 6D temp latest regulation and the introduction of the on-the-road measurement that succeed in efficiently reducing the emission level on the street. Of course, there is still exception that persist, and Euro 7, as introduced, will, I think, aim to even more ambitious objective for both the levels of emission, the test condition of the measurement, and the list of pollutants that will be extended. But the very important question for today's speech is to know if this panorama is strongly impacted by the introduction of non-fossil fuel, whose the main objective is to decarbonize the transport. So in order to give some answer to this question, I will present just a very recent result of a study we are leading with the Concaway, a study that is still ongoing. And the objective is to evaluate plug-in hybrid vehicles in real use of condition of use. So just to explain the perimeter of this study, we selected, in fact, the more state-of-the-art vehicle with the latest available technology. So it is two PHEV hybrid vehicles with the latest technology for thermal engine and after treatment technology. And we selected this couple because we have exactly the same hybrid architecture with one gasoline and one diesel thermal engine. These two vehicles have demonstrated very low pollutant emission level with standard fuels. On a past study we led past year for the French Ministry on a wide range of conditions. All the pollutants measured were well below the Euro 6 limit on a wide range of conditions. So it is, from our point of view, some kind of best-in-class vehicle that have been tested on past year with standard fuel. And the objective of the current study is to see if the status is impacted using fuels from renewable sources. So we tested these two vehicles both with standard fuel, E10 and B7, and 100% renewable fuels. So it is E20 renewable and 100% HVO diesel fuel. I will not detail all the setup configuration and tests that have been led, just to mention that we put in deep instrumentation of all the regulated and non-regulated emissions, with a specific focus on solid particle number, with measurement at the engine out and at the tailpipe of the vehicles, and also a lot of instrumentation about the vehicle operation in order to understand the control strategies. We make a specific attention to have realistic test condition. So we operated several RD tests on the roller test bench in order to have several repetitions of the same test, but all the speed and slope have been recorded for real RD test operated on open road. So it is a way to ensure that the test operated are really realistic, very realistic. So without any more detail, I will switch on a very synthetic view of the results. So on this summary table, you can see the trend induced by the switch from a standard to a renewable fuel. So for the gasoline side, from the E10 to the E20 renewable, and for the gasoline side, from the B7 to the HVO fuel. And for all the regulated pollutant, NOx, CO, THC, and solid particle number, but also as an information for the fuel consumption and CO2 ton-to-wheel emissions. So our conclusion are that the main impacts to switch on renewable fuels are mainly, of course, on the fuel volumetric fuel consumption due to energy density of the fuel, and to the tank-to-wheel CO2 emission due to the chemical composition. And you can see that these impacts are quite significant, with several percent changes. Of course, the main impact will be to the well-to-wheel CO2 assessment, but it was not on the field of this work, and we will address this question later. So focusing now on the local pollutant, that is the main point for today, we established that the impact are very low, both for engine out emission and tailpipe emission. There was still some impact on the THC and CO, but at some very low emission level compared to the Euro 6D levels. So the emission levels of these two Euro 6D temp vehicles are remaining very low with the use of fuel from renewable sources. So just to conclude with a few words, this short presentation, we've shown in this current study that the latest generation light-duty vehicle tested the impact on local pollutant that switching to low carbon fuel appear to be low. We will use these experimental results to feed a broader analysis on the performances of PHEVs and compare them to other level of electrification and conventional vehicle to fully electric vehicle. Just to open the discussion more generally about air quality, we are leading a lot of projects in order to use the new communication and information technologies, including the GNSS data and floating car data, to have a more detailed and localized understanding of real usage and the emission impact. And lastly, concerning PHEV, we are working on the optimization of use of the technology to deal with both global and local issues. And for example, on PHEV, the geofencing is the digital technology that will help to thwart zero emission mode in low emission zone for PHEV. So I will not take too much time. Wanted just to share this few results, and yeah, I will be happy to answer your question.
Thanks, Philippe. I think that's some great hard data that we can use to inform our discussion. Now, if you guys at home have any questions for Philippe, go ahead and type them in. If you have specific questions on anything you saw there in the presentation, I can read them out to Philippe if you type them in. So I want to ask you guys first specifically about Euro standards and what their effect has been. Paul mentioned some of the, that as a whole, I think, Paul, if I understood you correctly, the EU's approach to this seems to work better than the US approach, but we can come back to that. Dirk, let me ask you first, how have Euro standards for both light-duty vehicles and heavy-duty vehicles made a difference for air quality in Europe?
Yes, for sure. This constant evolution of the Euro standards that we have seen over time have indeed made or led to tremendous results, as we know the modern vehicles today. Over time, with the introduction of Euro 4 and 5, going back many years, we saw the introduction of the diesel particulate filter on the light-duty cars, diesel cars, and we got the first applications of the selective catalytic reduction systems on heavy-duty trucks. And then with Euro 6, it was the other way around. We got the diesel particulate filters on the trucks, and we had first DeNOx technologies consisting of LeNOx traps and SCR technologies on the diesel cars. So these emission legislation really drove the evolution of the technology, the emission control technology, combustion technology, engine technology, to work in an integrated approach, decreasing the tailpipe emissions. Of course, as Paul also said, there is some room for a Euro 7. One of the topics I would like to raise, for example, is that we currently, with Euro 6 legislation for the cars, we have a very good procedure for controlling the emissions in real driving conditions. But let's not forget, this is the first ever procedure that we know, even in the world. So from what we are learning today, I would say we can still draw a good set of lessons that we should include in Euro 7. And in addition, for heavy-duty trucks, as Paul said as well, we are still at PEMS testing for in-service conformity testing, but we are actually still lacking a real-world emissions procedure for heavy-duty. So I think the work is not yet done. We have room for a Euro 7, and what should be part of this Euro 7 is to be decided, but it's clear that the focus should be on getting as low emissions as possible to minimize the impact on human health of our European citizens.
Hey, you mentioned Euro 7, and Paul, I mean, when you mentioned that the industry itself, the automotive manufacturers, are working on these issues. So as we're talking about Euro 7 and what there's room for with Euro 7, what comes next, is it potentially a kind of distraction when we're talking about Euro 7 when that's happening at the same time as the automotive manufacturers are working on their own initiatives?
Yeah, that's an interesting question, David. Clearly, all efforts are being made by manufacturers towards CO2 targets. We have the targets for 2030, but we know they're going to be revised and to be made even more stringent. And perhaps then, at the same time as Fit for 55 and the outcome of the CO2 review for heavy-duty vehicles next year, we may even see targets being set for years beyond 2030. In the lead up towards a roadmap for what road transport should do in the eyes of the regulators towards achieving its impact for net zero by 2050. Now, I think it's clear that the industry itself has embraced all of that, and that is happening irrespective of what happens on Euro 7. And of course, as you replace existing vehicles or more low and zero emission vehicles come into the fleet for CO2 reasons, to meet targets or for other initiatives which some manufacturers are taking themselves, with statements about phasing out of their portfolio, including ICE products. then that will have automatically a knock-on impact on air quality. So you could say that is a big investment, that is a big effort in terms of engineering resources, which is being driven towards that agenda, training engineers to look towards that decarbonised future. Now, if you start then introducing a massively complex Euro 7 package, the consequence must be that a lot of that investment and a lot of that engineering effort has to be redistributed, which could lead to some impact on the rate of CO2 improvement, simply to divert non-finite resources towards Euro 7. Now, I said earlier that we're not against Euro 7. It does have a role to play, but considering what we've seen on the table so far, which would be a very severe set of emission limit scenarios, coupled with new elements and very big redesign of testing methods, which could take several years, there may be a better way of looking at that, to give industry clarity on a relatively ambitious approach for Euro 7, perhaps even in a shorter time frame. Just to put that into perspective, give industry the necessary clarity and lead time to get on with the job without disturbing too much the efforts which are having to be made anyway on the CO2. And we should realise also that the European Commission is not individual kingdoms in different DGs. There has to be joined up thinking across all of the European Commission, whether it's infrastructure for recharging, whether it's Euro 7, whether it's ambient air quality requirements, whether it's CO2. Presently, all of those are addressed by different DGs. But really, when you're looking at the complexity and the impact of all of these measures, it really does require some joined up thinking. And we think there are some sensible approaches to ensure that we keep making progress on CO2 and can introduce Euro 7 without rocking the boat too much.
Philippe, let me get your take on this when we're thinking about what's coming next in terms of NOx and PM limits. Based on your research, what do you think is really needed as next steps when we're talking about air pollutant limits?
Well, concerning the next step, there is still some very extreme condition and very, for example, the very short trip and very cold test where we can see some high level emission. So all the question is to know if this kind of usage is very representative or very frequent in real living situation. I think all the question is to know between a quick and the faster renewal of the vehicle fleet is, to my personal point of view, the more important point to address, because we have demonstrated in the past few years that the Euro 6 vehicle demonstrate very low pollutant emission level, but they are still representing a very low share of the current fleet. So yeah, the main objective is to accelerate the renewal of the fleet. Of course, there is still some progress to do with the local pollutant emission of next generation vehicle. I think the next challenges will be very critical situation as to accelerate the activation of the after treatment system on cold and short trip, and to take into account additional pollutant. It will be an important topic on Euro 7. Of course, it is, I think, planned to lowering the level, for example, the NOx emission, that may be decreased up to 30 milligram per kilometer. That is the latest scenarios. For the particulate, with lowering the diameter of measurement and to lowering the level of maximum emission, but also, of course, to take into account additional pollutant and, for example, the ammonia. will be the next challenges for the local air quality?
Well, we've had a question come in from the audience. Paul, I'm going to put this to you because this is a question very much related to this topic. So the questioner from the audience asks, some say that the new Euro 7 is being developed to ban internal combustion engine vehicles. What is the assessment of the experts? So Paul, do you share this suspicion that Euro 7 is being developed to ban ICEs?
It's a point to make that there is a high level of political interest to move away from internal combustion engines to zero emission powertrain. So in other words, electrified powertrain. We're never going to get there with internal combustion engine plus renewable fuels. But it seems to be a political move to push the industry towards electrification. Now, the CO2 regulations themselves are going to do that. And whether Euro 7 is being used as an indirect tool to accommodate that phase out of internal combustion engines, I won't use the word ban, because I don't know whether a ban could be legally enforced in many respects. If you consider, there is still lead in gasoline at very low amounts, but we know all the health implications of lead and the toxicity of lead, but it's never actually been banned. So to apply a ban to the internal combustion engine could be an interesting legal argumentation. So, but of course the regulators could set the Euro 7 levels at such stringency that no manufacturer in his right mind, particularly on the car side, would bother with it anymore, considering all of the efforts that they're having to do towards electrification. That could speed on the car side the road towards a much greater availability of electrification. Now, we have to be very cautious about that because there is a number of conditionalities that we have asked for as well, and that really is based on the recharging infrastructure. On the heavy duty side, it's a completely different picture. We think electrification is happening. Hybrid heavy duty vehicles are there. Pure electric heavy duty vehicles, buses and coaches are there, but it's not going to move at the same pace. And we see that there is a definitive need for the internal combustion engine to exist for commercial transport, complemented by the introduction of low carbon renewable fuels, we believe, in the transitional period up until when the heavy duty industry is capable of going widespread towards electrification. And for some manufacturers' views, that happens earlier than later. So the issue of a ban, we think, is there in the background. And what we've seen so far from the Commission consultants does actually lead us to have some concerns, particularly on the impacts we believe that those sorts of proposals, the limits, but also the limits combined with very, very severe testing conditions, could lead to the elimination of some internal combustion engine products, particularly small vehicles, which are never going to be able to be sold in terms of price competitiveness and packaging for all of the additional devices that would need to be on those vehicles. And when you get into the middle car segment, a lot of manufacturers offer basic options. Those will disappear because they simply won't be cost effective. For heavy duty vehicles, it's not a simple matter like that. There has to be a viable future for the diesel engine for commercial transport. And if Euro 7 came out at very, very severe, and that's not what we would recommend, but manufacturers would have to make the efforts because they need to continue to sell those. And the impact would therefore be on the customers and the operators in what we believe would be a very big increase in total cost of ownership.
Dirk, do you get the impression that Euro 7 is being developed with this kind of high-level goal of an ICE phase-out?
No, Dave, I don't think so. And I think we heard it in the ACFES meetings from the Commission that was confirmed that this was not, or this is not the purpose. Of course, in the process, we had a bit of confusion because the very initial scenarios that were presented by the Clover Consortium were actually very demanding, very challenging. But that has evolved between October last year and April this year, where we see now, let's say, feasible scenarios. Some of them, of course, the difficulty will be in the combination of all the different measures in Euro 7. So it's not mainly about reduction of limit values, but as we heard also from Philippe, it's about other issues, a broader range of testing, adding additional pollutants, etc. Perhaps also the topic of geofencing and zero emission capable driving in cities. All these topics are being discussed in Euro 7. As a package, it will then become quite ambitious and demanding, but I don't see that this is the purpose to phase out the combustion engine. And by the way, we should not simplify that everything can be fully electric. I think we as AECC, we believe in an all-inclusive strategy, in a technology-neutral approach, and we should have the best technology depending on the use case. There's a big difference between a small car running in the city and a big truck that has to be fueled by diesel. And there we think it should not be the ICE being phased out, but we should move towards more sustainable renewable fuels, and in this way, in the long term, phase out the fossil fuel. That's what we have to phase out.
I wanted to ask you guys as well, I kind of alluded to this in my introduction, but of course, air pollution and CO2 emissions are two different things, right? So you could get a scenario where you have non-fossil based liquid fuels that are much better for the climate, but could end up being worse for air pollution. Philippe, let me put this question to you. Is it possible that some non-fossil based fuels could lead to less carbon emissions, but also lead to more air pollution?
If they could, yes, it is in fact possible, because fuels of non-fossil origin do not have exactly the same composition and physico-chemical properties compared to standard fossil fuel, even if they are very similar. All the question is to be careful about this concern. It can therefore have an effect. It can be positive or negative on the combustion and the formation of local pollutant as NOx, CO, or particulate. And this is why we have to carrying out studies really dedicated on measuring these impacts and dedicated research and development on engine in order to improve the match between engine technology and calibration and the use of these non-fossil origin fuels. So yes, it can be it can have an impact on local pollutant, both positive or negative, and it is the work of engineers to optimize the next generation engine in order to minimize the local pollutant impact of this kind of fuels.
Paul, are the automotive manufacturers thinking about this possibility when they're looking at renewable fuels?
Within the association, David, it's a slightly difficult issue, this issue of fuels. I think everybody would agree that the internal combustion engine itself isn't the issue. It's what we've had to put into it to make the vehicle go forwards or backwards that's been the issue. And it's great to see that there are new options, low carbon renewable fuels that would replace fossil of one type or another. There is an element of nervousness about that because the use of such fuels has been demonstrated to help reduce CO2. If future targets were set on the basis of that fuel contribution and those fuels didn't come to the market for one reason or another, the vehicle manufacturers will be stuck between a rock and a hard place. So you can fully understand why, particularly on the light duty side, on the car side, that they want to take their future into their own hands. And there's been a less positive response to low carbon renewable fuels across the sort of car manufacturers at large. That's not to say that some are looking at it very, very hard in terms of options. But in general, if we were to rely on the availability of low carbon fuel to help meet our targets, that would be a big issue for us. So we have to take that responsibility into our own hands. Now, when it comes to commercial transport, we really need to see the introduction of low carbon renewable fuels. That has to have a role to play. But again, it's a question mark of whether that is taken into account in setting future targets, or they are in the market and the benefit that accrues when a vehicle uses these low carbon fuels is either there as a positive benefit to the environment and to the climate as these vehicles circulate, or some other advantage could be taken of the use of such low carbon fuels in the marketplace. So it's within the association, it is still a bit of a balancing act on the use of these fuels. But clearly, I think on a scientific basis, the case is there, and it's very clear that they can offer some good additional benefits for helping to reduce road transport emissions.
That's interesting. So a bit of a split there. Dirk, what's your take on this? Is that risk present that renewable liquid fuels could lead to more air pollution, and what could be done about that in terms of technologies?
Yes, of course, as it was said, we need to investigate all these different fuels because currently a lot of options for these renewable fuels are being discussed. I think what is important, first of all, is that we look at those renewable fuels that are, of course, sustainable, but that also have drop-in capability in the current market fuels. In that way, of course, we are minimizing the risk because they fulfill the European standards that are in place for diesel, petrol, and alternative fuels. And we can then also have the greatest impact because these fuels could then also be used in the existing fleet and could be used or dispersed to the vehicles using the existing infrastructure. So that is something that we as AACC are doing as part of our projects. So those fuels that we investigate in our projects, we believe they have a potential for use not only in the new vehicles under the Euro 7, and should there be any additional pollutants coming from this, then this is a topic for Euro 7 to be considered. So there is a link between Euro 7 and the topic of renewable fuels, but also for use of these fuels in the existing fleet where we will have the biggest benefit from it in the short term, at least.
So Philippe, I've had a couple of questions come in. Paul, you wanted to come back on that?
Yeah, I just want to expand on that a little bit. The point that Dirk made about the advantage of these renewable fuels providing benefit to the whole fleet as they fuel with them, that's absolutely correct. And that's one reason why, on the light duty side for gasoline, we have been pushing very hard to have improved gasoline to the marketplace. We have a high level of interest of improving, for example, octane, for obvious reasons of being able to take advantage of that guaranteed octane to redesign engines to make them more efficient. And you can deliver octane in a number of ways. You can do it through refined process, refining components, or you can add more renewable elements into it. Our view on that is neutral. We see benefits of using an E10 base, but improving the octane, which allows that E10 base high octane gasoline to be compatible with the whole fleet. If you deliver octane purely by going to E20 or E25, whatever the calculation is going to be, then unfortunately you would have a limitation on the availability of that fuel for vehicles going forward, vehicles which have been specifically engineered to be compatible with the exposure to higher ethanol in the fueling system.
Okay, so let's go to Philippe. I have a couple of questions that have come in for you about the data that you presented. So this question comes from Marnix Koopmans. What are the components of the 100% renewable E20 gasoline apart from the 20% ethanol that Philippe presented?
Yeah. This specific 100 renewable fuel, in fact, is accepted the level of ethanol is 100 compliant with the EN 2028 European regulation. So it is a very well good candidate to replace, for example, existing standard gasoline with available and actual current fleet. So I do not have here the detail of the pathway and the process to produce the fuel, but the properties are 100% compliant with the European certification for gasoline fuel, except the level of ethanol.
Okay, so another question for you, Philippe. How extensive have been the testing conditions compared to the Euro 6 boundaries in your different studies? And how low were the emissions measured?
Well, we have to differentiate two studies. In fact, one we led past year for the French Ministry of Ecology on 22 different Euro 6D temp vehicles, and we make a specific point to test the vehicle outside the Euro 6D boundaries in terms of dynamicity, for example, with very dynamic driving cycle with high slope at extreme temperature. And we demonstrate for these two specific vehicles very low emission level. So it is for all the pollutant considered half than the Euro 6D level. So very different from one pollutant to another. For example, for the NOx emission, we were for both diesel and the gasoline vehicle around 10 to 20 milligrams per kilometers, including in very dynamic and severe testing conditions. And what was the condition for these dedicated studies with renewable fuels? We, in fact, tested the exact same vehicle on Euro 6D compliant RD test. So the results I presented to you today are measured on 100% compliant RD test with Euro 6D certification.
Okay, we've had an interesting question come in here. Dirk, I'm going to put this to you. It's about basically, as a vehicle's lifetime goes on, does the situation of its air pollution contribution change? So the question is there any negative impact of vehicle usage on emissions levels? If a car has a $100,000 kilometer usage on it, does it emit more pollutants compared to a new vehicle? And likewise, does the emission control technology platform at the same level, does the emission control technology perform at the same level throughout the vehicle's lifetime?
Okay, thanks for the question, Dave. Of course, when the technology is new on the vehicle and then it performs throughout the lifetime of the vehicle, I think it is very key to keep the performance as it was planned to be from the beginning when the vehicle gets type approved. In the legislation, there are several measures foreseen from a durability testing at the type approval, but also the in-service conformity testing throughout the lifetime and the RDE testing now as part of the in-use compliance testing for the vehicle. In addition, there are topics like the periodical technical inspection, for example, that should pick up the big emitters, the outliers, which should then be sent to the dealer or to the garage for repair and replacement of the defect components. We also see increased usage of remote sensing devices that will monitor the emissions of vehicles on the road. And I think in that way we have a full chain of procedures and testings, if you want, throughout the lifetime of the vehicle, because the overall purpose, of course, is to maintain the good performance, emission performance of the vehicle as a system, of course the after-treatment system in particular, but we see that very much as a complete system. And the one thing to be avoided, of course, is that users start to misuse their systems, tamper, for example, with the emission control system. There are a lot of cases known that people remove the particulate filter, or now also there are gasoline filters, particle filters. This should not happen, of course. And to reduce the NOx, to have the good performance of the selective catalytic reduction systems, mainly on trucks, of course the system needs to be filled with the AdBlue. Otherwise you cannot have the performance. So a chain of different measures is in place to maintain the good performance of these technologies in the vehicle.
Paul, from the manufacturer's perspective, is there a deterioration of air quality performance over time for a vehicle?
Well, according to the regulations today, for cars, the vehicles can be checked up to 160,000 kilometers. That's the durability requirements in the Euro 6 regulation. Now, that's not to say that 160,001 kilometers, the emissions spike, exponentially. Manufacturers have got to be very careful about the design of their systems, and these systems get more and more expensive. There's a lot of precious metal in these after-treatment devices. And of course, yes, there will be some deterioration over time, but the obligation on manufacturers is that they have to meet the emission limits at that durability limit, and probably beyond. To be honest, manufacturers will have to do risk assessment, so they're not going to do it at 160,000 kilometers exactly, or 700,000 kilometers, which is today's requirement for the heavy-duty vehicles. And within that period, 160,000 kilometers, it's, how many people apart from commercial drivers are doing that sort of mileage? As Dirk has rightly said, we have type approval, we have conformity of production, checking vehicles coming off the production line. We have in-service compliance checking, we have fleet surveillance, we have periodical technical inspection. There are a lot of control measures to ensure that the vehicles are operating as designed up until those legal requirements. And in many respects, Euro 7 is looking to even go further. And what would that mean? I think it's going to mean increased cost, increased loading of precious metal in these after-treatment devices, and as Dirk has rightly said, increased efforts to reduce the opportunity for tampering of these systems, because I think customers may well be very reluctant to replace their catalyst after the vehicle has aged significantly with something which could cost them quite a bit of money. So we want to ensure that the customers do operate the vehicles as intended, do follow maintenance schedules, do ensure that they pass their periodic technical inspections as the vehicles get aged. And importantly, we've been banging this drum for several years as an industry to get the regulators to stop the availability of advertising and sale of these aftermarket devices, which can very easily be put onto vehicles and change completely the emissions performance of vehicles. It just seems crazy that operators or manufacturers are investing so much in Euro 6 technologies when operators can go on the web and buy a $20 unit that plugs in and defeats completely the Euro 6 performance, particularly trucks, to avoid consuming AdBlue, for example, to be a Euro 6 vehicle on paper, to qualify for tax reductions and operate in Germany according to lower MAG values on the motorways, but in reality emitting far more than those vehicles were ever designed to emit.
Philippe, what does the data say about the relation between a vehicle's age and its air quality performance?
Well, it's not only due to the age or mileage of the vehicle, it's very depending on the specific usage of this vehicle. And I fully agree with the previous statement. It is important to have efficient way to control and to ensure the efficiency of technology all along the life of the vehicle. For example, DPTI or the roadside technology measurement to ensure control. There are a lot of evolution recently on the regulation for the approval type testing with the RDE. We are thinking about testing some new methodology or new measurement for the PTI, also to ensure that the measurement we do during this periodical test are also representative of the real use of vehicle. It's not easy scientifically to have any assessment of the mileage or age impact. It exists, but it will really depend of the usage specifically of this vehicle and about the state of the vehicle. So we have to design some specific control strategy.
So we've had a question come in for Paul from the audience. So Paul, if small cars will never be able to be sold given the future regulatory requirements and financial impact, and the electric version of these small vehicles will also be expensive, as shown in the previous webinar, what are we telling consumers? That's a reference to our webinar last week where we presented some data showing that basically at the current moment, electric vehicles are not within a price range for most segments of society. So Paul, what's your answer to that?
Yeah, it's important to provide mobility to all areas of social capability. And that's a very strong view of our industry, whether those people live in cities or whether they live in rural and countryside environments. At the moment, yes, it may be the case that electric vehicles are on the expensive side. We hope that those prices will fall as the technology develops, as new technologies come along, and it seems that there is advances in the capability and the technology capability of electric vehicles moving forwards. What we really don't want to see is regulation forcing out access to mobility to people that can't afford it. And certainly we don't want to have the case where new regulations would encourage people who are owning Euro 2, 3 or 4 vehicles simply to hang on to those vehicles even longer, which is not good for the environment. There are ways in which we can improve access. And one thing that we did, for example, was on our studies on air quality, look towards other options than just a Euro 7 regulation, which we think is going to have actual minimum impact in the good air quality impact that the replacement of the existing fleet with latest Euro 6 vehicles is already having. When you couple that with the likelihood that Euro 7 could be quite expensive based on what we've seen, the actual cost benefit of Euro 7 just doesn't make sense. And we're finalizing a study on that using the same handbook of internalizing the external costs of transport, which the Commission said it will be using as part of its own impact assessment. So if Euro 7 would do that, that would be rather unfortunate. And it would, and other options like access to incentive schemes to speed the fleet renewal of Euro 6 vehicles, to encourage operators and customers to buy the latest Euro 6 vehicles, are easy measures. These are measures which have been included in the Commission's own recovery programme, and are measures which we believe, according to the studies, offer a 6 to 10 times benefit in terms of air quality improvement compared to anything that a Euro 7 regulation can do. So it is a concern for us, and we think that really does need to mean that you really have to look at a Euro 7 regulation in terms of that access, in terms of the affordability, and in terms of access for all social classes to continue to have access to mobility, which is their right.
We've had another question come in from the audience. This one will be for Dirk. So to meet 1.5 degrees, that is the Paris Agreement goal to keep temperature rise below 1.5, battery electric vehicles and fuel cell electric vehicles will not be sufficient. even if all new vehicles from today would be battery electric or fuel cell electric vehicles. And renewable drop-in fuels will be needed to replace fossil fuels, at least for the legacy fleet. Should very clean, effectively EU7 ICEs, therefore not be a long-term alternative to battery electric vehicles and fuel cell electric vehicles? And I think the key word there is long-term.
Yeah, thanks for that question. Again, of course, as I tried to say, we believe very strongly in the clean ICE Euro 7 for the future, but in combination with the increased uptake of the sustainable renewable fuels. And by the way, we as ACC, we sent an open letter to 5 commissioners on this, calling for an ambitious Euro 7 and uptake of more renewable fuels. Unfortunately, still awaiting the written response from the Commission. But I think for the future, we need the mix of all the powertrain options. Our members, ACC members, also produce materials for battery electric vehicles, for batteries, for fuel cells. And we think it's really having this mix of options available for the future and leaving the user, professional user or the private consumer, the choice of the option for the future. Of course, we have to take care that all these mobility options contribute to the long-term strategy of having carbon neutrality in 2050. But what is very important is not only the target of carbon neutrality in 2050, but it's the way towards 2050, this whole transition. And in this case, I think we can have the fastest results also from the legacy fleet, the existing fleet, by using more and more sustainable renewable fuels for new vehicles, but also in the existing vehicles.
We've had 2 more questions come in for Paul. Paul, I'm going to ask you both of these at the same time because they're related. First question is from João Manuel de Reis. ASEA is strongly demanding for more electric charging points in Europe, which is a recognized need, not only for the reduction of emissions, but also as a marketing condition for the sale of electric cars. Aren't you afraid that if the requested increase of charging points doesn't become a reality, even due to the limitations of the electricity grids, that customers will continue to buy ICE vehicles? And another related question from Marnix Koopmans. Does Paul think that the end game of heavy-duty vehicles will be full electrification, or will the ICE on low-carbon fuels take a sustainable market share nearing 2050?
Yes, well, thanks for the questions. On the charging, it's again this chicken and the egg situation. And what we're seeing in terms of the implementation of the Directive on Alternative Fuels Infrastructure, which is setting targets for access to recharging, it's not moving fast enough. And we're simply asking the Commission and the Member States to do better, because I think there is a pent-up demand growing amongst the public to have access to electric vehicles. I'm a petrol head myself, but performance of these vehicles is quite amazing. So there is a real need to ensure that the growth is matched by the availability of charging. And in many respects, the availability of charging has got to be in advance of the growth in the purchasing and sales of electric vehicles, to make it sense. And we hope that the review of the AFID, we hope that whatever comes out in Fit for 55 package will be rather more ambitious in putting pressure on the member states to deliver that recharging infrastructure. You know, people who have a driveway, it's fine. They can have access to funds to fit a charging station on their wall, but you've got to try and cater for all elements of society who don't have that availability of parking and overnight charging capability. So that's a very important thing, and it was that's one thing that we have actually communicated jointly with the NGOs on that to the Commission. That's great. On heavy-duty vehicles, transition towards electrification of the new heavy-duty vehicle sales will take place, but obviously that transition will require still the improved ICE and hopefully with improved fuels. There will be a situation even when we get to 2050 that perhaps not all heavy duty types of vehicles will be electrified. It will be impossible to foresee that. Some of these massive vehicles simply cannot be electrified, particularly those in the north of Sweden or Finland or other areas, massive vehicles for which the internal combustion engine fueled with improved fuels would be the only option. Electrification simply doesn't work necessarily for all of these niche types of heavy duty applications.
Thanks, Paul. Well, that's all the time we have for today. I want to thank our panelists for some great interventions, and also thanks to the audience for spending your morning with us and for asking some great questions on your own. And indeed, I hope you enjoyed the whole Refuels Week series. I think what we definitely discovered during this series is that these are issues that are being watched very closely, and so much is going to depend on this Fit for 55 package that's coming out, expected mid-July, maybe a bit later from what I hear. But everyone's very, very keenly watching that, and that's going to make a big difference, I think, for how we think about vehicles going forward. And of course, vehicles are just going to be, transport is really just going to be one part of that massive package in July, but it's one of the biggest parts of emissions, of air pollution. So we'll see what happens with that. So thank you all for spending your morning with us, and I wish you a great afternoon and a great rest of the week. Bye-bye.
All right, David.
Thank you, Dave.
Bye.